Hello, everybody. Welcome to another installment of Biology in the Basement with your host, Mr. Andraco. Special edition base showcase. I took all the action figures down. They were just falling over all the time. I do lots of work on this table and they just kept falling over. And so I figured we'd get rid of the action figures and display the bases for this new series. When we get into skin, muscle, and bone, hopefully we'll cover this table with all kinds of bones as we talk about the skeletal system. We'll try to keep Bonesy's clothes on, but he may have to disrobe for some demonstrations of how our bones fit together and joints and things like that. So hopefully we'll keep your clothes on, but who knows? Sign of respect, Bones. Okay, so yesterday we talked about the real basics. Just what is a disease, immunity, where does it come from, what is a pathogen, as well as vectors for diseases. Today, as you can see here, I got this fancy table that will go over all the lines of defense, and that's what we're going to focus on today. But before we get started, we need a fact of the day, and here we go. Turns out if you have allergies, scientists believe that our allergies and those genes from allergies, which we'll talk about later this week, come from your background with Neanderthals. We share DNA with Neanderthals. Some of us have Neanderthal DNA. There was some crossbreeding back in the day, and they think that some of our allergies, specifically to hay and dander from animals and things like that, and pollen, most likely have come from our Neanderthal ancestors. So there you go. There's your fact of the day. All right, quick review, and then we will talk about the 3 lines of defense. So your immune system is has a foundation, I should say, in your bone marrow. That's where your white and red blood cells are made. And so the white blood cells come out. Some of them just do their thing. Some of them go through a series of training camps and become special forces and specific fighters, which I'll talk about while we're setting up this table. And I'll even share a super cool video as well of how our immune system can fight off bacteria, I think is in that video. Working with the lymphatic system, of course, is another helper in the immune system so that we can fight infection, pathogens, keeping ourselves free from disease, disruption of homeostasis. Right? It's not just caused by pathogens, but it can also be caused by toxins in the environment. I talk about this in my forensic science class. When we do forensic toxicology, we don't just talk about drugs. We also talk about pollutants in the air, water, and in the ground, so that we can have a cleaner environment, safer for everyone, because there's a lot of people who are getting cancer from toxins in the environment. Another example of diseases not caused by pathogens. But that is the part of the immune system that we are going to be focusing on. Are these pathogens? Now, they're called agents because they're not all living things. They're not disease-causing microorganisms or organisms, though the protist, bacteria, worms, and funguses are. Viruses are not, and all these toxins from the environment are not. So we'll just call them disease-causing agents. Now, we can get them from person to person, person to animal, just taking them in from the environment, right? If there is an animal involved, we call that a vector. This is one of the reasons why we are practicing social distancing and wearing a mask, because the biggest vector for disease is members of the same species. Since the DNA is so similar, it's very easy for these pathogens to just jump from one person to the other. So practice your social distancing and wear your masks. We used to talk more about insects in malaria, the fleas on the rats when it came to the Black Plague as being vectors, but the list goes on and on depending on where the conversation would go in our classroom. But unfortunately, we are not together yet. Hopefully soon. Fingers crossed, we'll see you again. All right. So, here's what I want you to do. I'm going to tell you a little fun story about how badass your body is while you guys prepare to get this information into this table. So hopefully somewhere in your notes or on a separate sheet of paper, I want you to draw this table. While you are drawing this table, I will tell you a little story about how awesome your body is. Okay? So, get a sheet of paper. Take your time. There's lots of weird lines and cuts and all these things in here. So take your time because this story will take a minute. Usually I get super animated, but I'll give you the dialed down version. But your body is awesome. Imagine a fortress. Imagine the greatest fortress that you could ever think of. Like that an army of armies would attack. You know, whether you're picturing all those orcs going after Helm's Deep, or you're thinking about whatever space age movies you like, or if you're into history, you're thinking about the cavalries of thousands of men going into battle. Imagine any of those scenes where they're attacking a fortress. Your body is better than any of those fortresses are when it comes to battling microbes. Okay? Let me give you a few examples. Your first line of defense is skin. Now, to you, your skin seems kind of wimpy, but it's pretty tough. Okay? You're always bumping and rubbing and scratching into things, and you don't start bleeding all the time. It can take normal wear and tear, right? Plus, it can hold off the basic microbes. Also, it's a layer of dead skin, right? This is done so to protect against UV rays, but also it just flakes right off. So imagine your army is climbing up the wall of the castle to try to get where they're going, and the wall just shakes off, and all of those warriors just crumble to their death because the wall just sheds a layer and a new wall is underneath it. Okay? I've never seen a castle that can do that. Your skin does that. That's pretty awesome, right? You just go like this, and bacteria has just fallen off of your body. Okay? So your skin is great. Not only does your skin do that, but you also have oils on your skin that make it difficult for different pathogens to move around. They get gobbed up in the oils of the skin. Yes, you get acne from it sometimes because it's trapping dirt and all of that business, but those oils are preventing these from getting any further into your body. So those are good. Not to mention that we have to protect all the openings of the body, right? We're not completely covered in skin. So we have things like hair, mucus, saliva, okay? That also in it has, this is where I'm trying to control myself, an enzyme in it called lysozyme. So imagine that this castle has a moat, okay? Or at every opening that you would try to go through, there is a liquid and there is some kind of a moat maybe where you have crocodiles in there, right? If you try to get into your mouth, your saliva not only will kill you, but it will just spit you right back out. Okay, same thing in your mucus. Microbes come in through there. You've got a moat full of crocodiles killing all that stuff. Your mucus, even your tears, also have this lysozyme in it that are literally sharks with laser beams in a moat. Okay. Not to mention, if you eat something, right? All food has bacteria on it. You know, hate to break the truth to you. Of course, most of it has very little. That's why because we refrigerate and we keep it clean and all that stuff. But there's always a little bit on there. No big deal. Your stomach acids, digestive juices, kill it. It's when you're consuming food that's covered in bacteria because it's been sitting out for a week. Yes, your body can't handle that on a regular basis. But that's part of it. And so, when we look at this, we're really just looking at the walls and the exterior defenses. And so, this is just the first line of defense, not to get anything in or get established. Okay? So, for this first line of defense, oh boy, we forgot our marker. Bonesy, you packing? No. For our first line of defense, what we will put are the things that are involved, right? So we've got skin. We've also, can't forget to mention hairs, right? In our nose, cilia, in our respiratory system. And then we've got saliva, tears, mucus, right? All containing lysozyme, right? A bacteria killing enzyme. Crazy. 2 enzymes in your saliva. Amylase to help you digest, lysozyme killing bacteria. Who knew how cool saliva is? We also include stomach acids. Don't forget earwax. It's gross, but it is important. And of course, other lipids, right? Your oils that are on your oils and sweat, we'll call them. Okay. So, right, I've got here all of these listed. What is the goal of the first line of defense, right? This is to keep pathogens out. And of course, the first line of defense is what is considered non-specific. Okay, we don't care what it is. If it's not invited, we don't want it. So it is a non-specific defense that is just to keep whatever is not invited out. Okay? On to the next line of defense. This is where we've been cut, we've been injured, we've been overwhelmed, right? Where if there's a cut and lots of bacteria or pathogens enter in, we have our first line of defense cracked and we're into the blood or body tissues. And so the first line of defense has been defeated, so we have to go to our second line of defense. Our second line of defense is when we start to kick it into high gear. Okay, could you imagine if you made it inside of the castle and the castle just caught fire and it was so hot that you couldn't even move? Well, that's what the second line of defense is. It's called the inflammatory response. Right? This is inflammation, you may have heard, right? So in that little block, we call that the inflammatory response. This may be general or it may be localized to one specific part of the body, but the symptoms are all the same. You're going to see redness in that area, which of course means there is an increase in, what in the body is red? Oh, yeah, increase in blood flow to the area. Right? You guys have all had injuries and cuts and bruises where the area got red. Well, that's because they're sending more blood to that area. What's nice is inside of that blood is also an increase in white blood cells. We'll just call them WBCs, right? As well as extra fluid to wash away pathogens. And of course, you can't have inflammation without an increase in temperature, which we call that a fever. Now, here's something that you may not have known, is a fever is self-inflicted. You do this on purpose. Like I said, you jump in and you're like, sweet, we made it inside the body. And then all of a sudden, giant torches just start spraying in the hallways, just trying to cook you. Your body does that on purpose. Yes, it sucks to have a fever, but it makes it way more difficult if you're a one-celled organism than if you're a trillion-celled organism. So, this is self-inflicted, and its purpose is just to make specifically reproduction and other processes difficult. Processes difficult. Okay? And so what I've just got here, right, is the inflammatory response includes redness, which means there's an increased blood flow to that area, white blood cells. We've got fluid coming to that area, extra plasma, hopefully. We've got antibodies. Maybe it's something we've already bumped into before, ready to go to take care of that. And we'll talk about those down here. And then the fever kicks in. Sometimes it's a full body fever, but sometimes if you've just had a nasty bump or bruise or cut, that spot itself will feel hot. Okay, so that's what that is. Now, a couple other squares we have to fill out here. What is the goal? The goal here is to keep pathogens from spreading. This is our quarantine method, where they circle the wagons, right? They want to get the red blood cells surrounding that area, usually, if it's a deep wound or something bad, like a burn or whatever. They want to just quarter off that area, quarantine, and keep pathogens from spreading. Now, here's the tricky one. Does this sound like a specific or a non-specific response? Oh, spoiler, it says it right there. We're still just using regular old white blood cells here. We're just turning up the heat. We are just using the white blood cells. This is non-specific. We have not called in the special forces yet. But remember, white blood cells are what are called macrophages. They're giant cells. These are giant bullies that show up. You know, it's just like sending a bunch of meatheads in so that you can just have the muscle in there to take them out. Okay. I feel like this video is running long, and this last line of defense is going to take a while to explain. So I'm going to cut the video here, and I will do a second video that will explain the third line of defense. Okay, for now, this is Andraco signing off, and we'll see you in a minute.